Hi, I'm Ms. Nell. I'm your instructor, and this is college algebra. The first thing we're going to look at is actually not college algebra, but it's something that we really need, and that's fractions. So, the first thing, the top number in a fraction is the numerator, and the bottom number is the denominator. So, in the fraction 7 over 15, 7 is the numerator, 15 is the denominator. A proper fraction is a fraction where the top number is less than, strictly less than the bottom number. An improper fraction is any fraction where the top number, the numerator, is greater than or equal to the bottom number. So 4 over 4, negative 7 over 5, 15 over 2, those are all improper, but improper fractions are fine. I prefer improper fractions to mixed numerals. So a mixed numeral would be, for instance, if we had 15 over 2, I know that 2 goes into 15 7 times with a remainder of 1. So we would say that 15 over 2 is equivalent to 7.5. But this is not the way I want you to write the answers. If you have a fraction as an answer, leave it as a single fraction rather than a whole number next to a fraction. Okay. Oh, yeah. And this is really, really key. I have known loads of improper fractions, and they vote, they are committed parts of their community. They're good people, really. So we like them, we don't mind them, we're happy that they're there. Let's remember something, because we're about to look at prime factorization. A prime number is a number whose only factors are itself and 1. So what the heck? So let's see. 1, by definition, cannot be a prime number because itself and 1 have to be separate numbers. So 1 doesn't get to work. Let's just write down the next several numbers. Okay. 2. Well, I know 1 will go into 2 and 2 will go into 2. In other words, if I have 2 divided by 1, I get a whole number answer. And if I have 2 divided by 2, I get a whole number answer. So that's what I mean when I say 2 will go into 2 and 1 will go into 2. But no other number will go into 2 and leave a whole number answer. So 2 is prime. What about 3? Well, I know 1 will go into 3 for sure. 3 goes into 3 for sure. Always, any number, itself and 1 go into it. Does anything else go into 3 evenly? Well, 2 is the only number we can check. And 3 divided by 2, 3 divided by 2, 3 divided by 2. 3 goes into 2 once. 1 times 2, that's 2. 3 minus 2 is 1. Then we have to bring down the next number. So I have to put a decimal and put a 0 and bring it down. 2 goes into 10. 5 times. This is not a whole number. This is a decimal number. So 3 is prime. Nothing goes into 3 except 1 and itself. Hey, maybe they're all prime. Well, let's check 4. So certainly 1 goes into 4 and 4 goes into 4. Does 3 go into 4 evenly? That's right. No, it doesn't, because 4 divided by 3 is 1.3333. It's a decimal number. But what about 2? Does 2 go evenly into 4? If we have 4, can we divide it by 2 and get a whole number? And yes, we can. So 4 is not a prime number. Okay, well, groovy. What about 5? I know 1 goes into 5. 5 divided by 1 is 5. And I know 5 goes into 5 because 5 divided by 5 is 1. So the only numbers we need to check are 2, 3, and 4. Well, 5 divided by 2 is a fraction or a decimal number. 5 divided by 3, same thing. 5 divided by 4, same thing. So yes, yay, 5 is also a prime number. What about 6? We know 1 and 6 go into 6. Does 2? 6 divided by 2, we can write it this way, 6 divided by 2, or we can write it 6 divided by 2. Either way, 2 goes into 6 3 times. 3 times 2 is 6. If we subtract, we get 0. Yes, that's a whole number. And 3 goes into 6 evenly. 6 divided by 3 is 2. So 6 is definitely not a prime number. And let's kind of speed up. So 7 is going to be prime. 8, we can say 8 is 2 times 4. So 8 is not prime. 9, we can write 9 as 3 times 3. So 9 is not prime. 10, 5 times 2 can be written as 10. So 10 is not prime. What about 11? That's right. 11 is prime. Let's see. Come up here. What about exactly 3 times 4, 6 2 times 1, 13? Good. 13, 14, 7 times 2, 18, 3 times 5, 16, loads of ways. We've got 2 times 8 times 6, lots of ways, 16, but 16 times 17, 17. Oh, hey, nothing goes evenly into 17, nothing before it. So 17 is a prime number. 18, that's 2 times 9. It's also 6 times 3, so loads of ways to write 18 besides 1 times 18. 19, that's right, 19 is another prime number. And I want to give you a list of the first, say, 20 prime numbers that I want you to copy into your notes. So the first 20 prime numbers. Well, we've already got some of them. There's 2, 3, 5, 7, 11, 13, 17, 19, and then 23. You would think 21 might be, but 21 can be written as 3 times 7. 22 is 11 times 2. 24 can be written loads of ways, 6 times 4, 8 times 3. 25 is 5 times 5. 26 can be 13 times 2. I guess that's its only factoring, but still it's got one. 27, 9 times 3. 28, 14 times 2, 7 times 4, 29. 29 is the next one. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 31 is next. That's 11. 37, 41, 43, 47. Let's see how many we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's stop at 15. So please copy these 15 numbers into the front part of your notebook so that you can refer back to it. These are the first 15 prime numbers, and we're really going to use those numbers and that idea a lot in our course. So let's go back to these notes. It says we want to look at a prime factorization. Well, that's writing a number as a product of only prime numbers. So let's see. Let's look at an example of that. Let's write 24, is that sure? Yes, as only prime numbers. Well, I'm going to use my list. I'm going to use my list and start at the beginning and see what works and what doesn't work. Does 2 go into 24? Yeah, sure, because 2 times 12 is 24. 2 is a prime number, so we don't have to keep going there. 12 is not a prime number, so we have to keep going there. Does 2 go into 12? Again, so yes, it does. That's right. 2 times 6 is 12. 2 is prime. We're done there. 6 is not prime. That's right. Does 2 go into 6 again? So can we use 2 again? And yes, we can. And this time, finally, both numbers that come out are prime numbers. So let's gather. We've got 1, 2, 3 2s. So 24 is 2 times 2 times 2 and 1 3. So times 3. And we're going to write this as 1, 2, 3 as 2 cubed times 3 to the 1 because we've got 1 3, and you don't need to write the 1. But if a number does not have an exponent, this little number, then the exponent is 1. So the prime factorization of 24 is 3 times 2 times 2 times 2, or more compactly, 2 cubed times 3. And going back to the notes, we're going to reduce fractions. And the steps are to write the prime factorization of the numerator and the denominator, divide out all matching or common factors, the factors that are left make the answer. Multiply them up and you've got the answer. So let's see. Example 1 is to reduce 2,520 divided by 7,700. So let's see. 2,520 divided by 7,700. And is there something we can do with those zeros? Very good, yes. When numbers above each other, or above and below each other, have a matching zero on the right, we can strike it out. And that's like dividing numerator and denominator by 10. So we're allowed. And that means that we want to find the prime factors of 252 and of 770. And I'm going to go in order with my prime numbers and start with 2. I know that 2 will go into this number because the rightmost digit is 0, 2, 4, 6, or 8. So 2 goes into a number if the rightmost digit is 0, 2, 4, 6, or 8. And in this case, that it is true. The rightmost digit is one of these 5 numbers. So let's see. 2 goes into 2 one time. 2 goes into 5 2 times, but there's a remainder. Because 2 goes into 5 2 times, 2 times 2 is 4, and we have a 1 as a remainder. I'm going to write that 1 in front of the next number. And now I want to see 2 goes into 12. And yes, it does. 2 goes into 12 6 times. Now, I know that 2 will go into 126 because the rightmost digit is a 6, and 6 is one of these. What is another way that we could describe numbers where the rightmost digit is 0, 2, 4, 6, or 8? Exactly right. Those are even numbers. So if you have an even number, 2 will go evenly into that number. 2 goes into 12, and I'm skipping the first number because 2 doesn't go into 1 by itself. So I'm looking at the first 2 together. 2 goes into 12 6 times, no remainder. 2 goes into 6 3 times. Does 2 go into 63? Excellent, excellent. It does not, because this 3 is not 0, 2, 4, 6, or 8. 0, 2, 4, 6, or 8. It's not an even number. The rule for 3, whether or not 3 goes into a number, so 3 into a number, if you add all the digits and keep adding all the digits, until you have only one number. One digit. If that digit is 3, 6, or 9, then 3 will go into the bigger number. And let's look at an example where we have to add more than once. So what if we had the number, let's see, 1, 8, 7, 2. And we want to see, does 3 go into 1872? Well, I'm just going to add 1 plus 8 plus 7 plus 2. 1 plus 8 is 9. 9 plus 7 is 16. 16 plus 2 is 18. But 18 is 2 digits. So I'm going to add again. 1 plus 8 is 9. And I have a single digit, and 9 is one of the numbers. And let's check. Does 18 really work? Does 3 really go into 1872? Well, 3 goes into 18 6 times. That's nice. 3 times 6 is 18, so we have nothing remaining. Bring down the 7. 3 goes into 7 twice. 2 times 3 is 6, so we subtract 6. 7 minus 6 is 1. We bring down the 2. 3 goes into 12 4 times, no remainder. So it works. We're going to use this technique very often. Well, let's pretend we can't see that 3 will go into the new number. We can use the rule of 3 to see that 3 really does go into 63 by adding the digits. 6 plus 3 is 9, and 9 is one of the happy numbers. So 3 really will work. 3 goes into 6 twice. 3 goes into 3 once. Yay! And let's pretend we don't know our multiplication tables, and we don't know that 3 goes into 21. If I add 2 plus 1, I get 3, and 3 is one of the happy numbers, 3, 6, or 9. And we all know that 21 is 3 times 7, and 7 is prime. So we've gone all the way to prime numbers. Now let's gather them. We had 1, 2, 2 2s, 2 3s, and 1 7. So 252, 2 times 3 times 7. I had 1 7, 2 2s, and 2 3s. So 2 squared times 3 squared times 7 is the prime factorization of 252. Well, now let's find the prime factorization of 770. And let's first ask the question, because it's nice to start in order, does 2 go into 770? And that's exactly right. Since the rightmost digit is 0, 2, 4, 6, or 8, this is indeed an even number, and 2 will work. And we're going to use the weird dividing shorthand again. So 2 goes into 7 3 times, but 3 times 2 is 6, so we have a remainder of 1. 7 minus 6 is 1. I put the 1 right in front of the next number. 2 goes into 17 8 times. 8 times 2 is 16. 17 minus 16, we have a remainder of 1 again. 2 goes into 10 5 times. You don't have to do this form of division, you can divide using long division. So you could write this as 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. Bring down the 7. 2 goes into 17 8 times. 2 times 8 is 16. Subtract 17 minus 16 is 1. And then bring down the third number. 2 goes into 5. 2 goes into 10 5 times. The thing I like about this method is that it's all contained in the original problem. All the thinking. Now, does 3 go into, what is that? Oh, I guess it's just a mark. Does 3 go into 385? So let's see. 3 plus 8 plus 5. 3 plus 8 is 11. 11 plus 5. That's 16. That's 2 digits. We need to keep going. 1 plus 6. That's 7. We're down to a single digit, but this is not 3, 6, or 9, so 3 will not work. The next prime number after 3 is 5. So let's try 5. And the rule of 5 is that if the rightmost digit, so let's write this here. The rule of 5 is that the rightmost digit must be 0 or 5 in order for 5 to go into that number evenly. Okay, so we do have a 5 in the rightmost place, so let's divide by 5. 5 doesn't go into 3, so we're going to look at the first 2 digits together. 5 goes into 38 7 times. 7 times 5 is 35. 38 minus 35, that leaves 3. So I'm going to put the 3 next to the next number. 5 goes into 35 7 times. No remainder, that's good. Does 5 go into 77?